OSPF version 3 classic configuration and also troubleshooting. In this video, I'm going to review the classic configuration for OSPF version 3, and after that we can talk about some of the show commands that we can use them for troubleshooting of the OSPF version 3. Finally, we will experience 2 trouble tickets related to the OSPF version 3 classic configuration. As I mentioned in the previous videos, today's we don't use the classic configuration of the OSPF version 3 because the classic configuration of the OSPF version 3 only is supporting the IPv6 routing, but with the address family configuration of the OSPF version 3, we can route both IPv4 and also IPv6 address family. Because of that, maybe this is a little beyond the scope of our course, but let me to review the classic configuration because it is useful today in some networks. In some networks, maybe the implementation of the OSPF version 3 was occurred with the classic configuration. Because of that, we should know about the syntax of configuration and also how we can use the show commands for troubleshooting the classic OSPF version 3, and also for example how we can increase the efficiency of this network. But before talking about the classic configuration of the OSPF version 3, let me to say that everything that you have learned about the OSPF version 2, okay, are available here. Actually here I'm not going to talk about the concepts because you have learned about the concept of OSPF version 2 and also the new concept of OSPF version 3. Actually we can say that you know everything, but here we are experiencing the new type of configuration, classic configuration. Don't forget that with classic configuration only we are routing IPv6, but with the address family configuration, the method that you have seen before, we can configure OSPF version 3 for both IPv4 and also IPv6. Let me to start with a simple scenario. It is so informative. Here we have 3 routers, R1, R3 and R2 and R3. As you can see here, we have only IPv6 addressing. First, we should configure this scenario with the classic OSPF configuration. Look at here, the configuration is so easy. First, we should enable IPv6 unicast routing, and after that, instead of using the router OSPFv3 process ID, we should configure IPv6 router OSPF process ID. Okay, you know that in OSPF version 2 we are using router OSPF. Okay, in the for example in OSPFv3 address family we are using router OSPFv3, but here we are using IPv6 router OSPF. Let me to review some of the command that you have learned before. Look at here. For example, assume that we want to configure OSPF version 2. Okay, for OSPF version 2, we are starting with this command, router config, then router OSPF PID. After that, we will enter to the router config router, and you know that here we are using the network command, for example, and this is for only IPv4. Actually, we are using OSPF version 2 only for IPv4 routing. Also, you have learned about the OSPF version 3 address family. Okay, in the OSPF version 3 address family or AF mode, we are configuring router OSPF here v3, then process ID. After that, here we are using we are configuring for example router ID, and after that we should go to the interface, and on each interface we are configuring the OSPF. Okay, this is the OSPF version 3 address family. Also, we have another method, OSPF version 3 classic, the method that I am going to talk about. That in classic method we should start with the IPv6, okay, router OSPF process ID, not OSPFv3. Okay, and after that we will go to the router config RTR, not router config router. Here also we can configure router ID, and then after this configuration we should enable the OSPF process ID, for example 1, and also area, some specific area on the interfaces. Actually here you can see the 3 methods of configuration. You know that this method now is expired and we shouldn't use it, but here in this video we are reviewing this method. But in the real world we should use OSPF version 2 if you have only IPv4, and OSPF version 3 if you have only IPv6 or both IPv4 and IPv6. Okay, let me to start the configuration of this scenario. It is so easy. Starting from the router 1, In router 1, we have three interface, a serial 10 IPv6 address. Okay, then we should configure a 2001 db812:1/64, and then no shutdown. The first command serial 10. After that, interface serial 11 IPv6 address 2001 db813. Okay, :1/64. Again, no shutdown. And finally, interface loopback 0 IPv6 address 2001 :1/128. And this is the configuration of R1. Now let me to configure the router 2. Conf t interface serial 10 IPv6 address 2001 db812:2/64, and then no shutdown. And after that, interface loopback 0 IPv6 address, okay, 2001 :2/128. And after that, the router 3 interface, for example, serial 10. And here we should configure IPv6 address 2001 db813:3/64, and then no shutdown. After that, interface loopback 0 IPv6 address 2001 :3/128. That's it. Now we should enable the IPv6 unicast routing on all of these routers, router 1 and then router 2. Okay, and finally router 3 IPv6 unicast routing. That's it. After that, we should enable the OSPFv3 classic mode. Example, starting from the router 1, here we can use IPv6 router OSPF1. Okay, then router ID, here we should configure router ID as quad 1. After that, we can configure the command interface serial 10. Here we should configure IPv6 OSPF1 area quad 0, assuming all of these routers are residing in area 0. That's it. Interface serial 11, again IPv6 OSPF1 area quad 0, and finally on the loopback 0 IPv6 OSPF1 area quad 0. This is the configuration of R1. And then in the R2, okay, again IPv6 router OSPF1, router ID is quad 2. After that, interface serial 10 IPv6 OSPF1 area quad 0, and then interface loopback 0 IPv6 OSPF1 area quad 0. Finally, router 3, first IPv6 router OSPF1, then router ID is quad 3. After that, interface serial 10 IPv6 OSPF1 area quad 0, and also interface loopback 0, again IPv6 OSPF1 area quad 0. Now we have neighborship between the router 1 and router 2 and router 3. Let me to show you. For verification, okay, we should use this command. You have learned about this command for IPv4, but here only instead of the IP you should use IPv6. For example, instead of show IP protocol, you should use show IPv6 protocol. Instead of the show IP OSPF interface or interface name brief, okay, you can use show IPv6 OSPF interface name or show IPv6 OSPF interface brief. Instead of the show IP OSPF neighbor, you should use show IPv6 OSPF neighbor. Instead of show IP OSPF database, we should use show IPv6 OSPF database. And finally, instead of show IP root, we should use show IPv6 root, include OSPF, for example. Okay, starting with the show IPv6 protocol. In show IPv6 protocol, as you can see, we can find the router ID, we can find the number of areas this router is residing, is connecting to those areas. For example, here we have only one area, and this is normal. If you want to find the stop area and also NSSA area numbers or count that we have connected to them, here with the show IP protocols, we can find them. Here you can see we have three interface, loopback 0, serial 10, serial 11. All of them are residing in area 0. As you can see, we don't have redistribution. We can use these options, this information for some features and also some troubleshooting. Also in the router 2, let me to show you the status of this command. Show IPv6 protocol. Again, we have IPv6 routing protocol is OSPF1, router ID is quad 2, number of areas is 1, normal area, 0 stop. stop, 0 NSSA. We have two interface in area quad 0, loopback 0 and serial 10, and we didn't do the redistribution. Also in the router 3, let me to show you, show IPv6 protocols. Here, as you can see, IPv6 routing protocol is OSPF1, router ID quad 3, number of areas is 1 normal area, 0 stop, 0 NSSA, and we have two interface in area quad 0, loopback 0 and serial 10. We don't have any redistribution. All right, now let me show you the next command, show IPv6 OSPF interface name or brief, starting from the router 1. Show IPv6 OSPF interface brief. Okay, look at here. We have three interface, three OSPF enabled interface, loopback 0, serial 10, serial 11. All of them are working under the OSPF process 1, and after that are members of the area quad 0. Interface ID of loopback 0 is 10. Interface ID of serial 10 is 5, and interface ID of serial 11 is 6. After that, here you can see the cost of each interface. Loopback 0 is 1, serial 11 and 10 is 64, and the state of loopback 0 is loopback, and the network type of the serial 10 and 11 is point to point. We don't have any neighborship on the loopback 0, but we have one neighborship on the serial 10 and serial 11. Also, let me to show you the show IPv6 OSPF interface, for example, serial 10, because I'm going to show you the detail. Serial 10 is up, line protocol is up, link local address is this link local address, interface ID is 5, area quad 0, process ID is 1, instance ID is 0. You know all of this information because I have explained them before. Router ID is quad 1. In this router, network type is point to point, cost of this interface is 64, state of this interface is point to point, and here you can see the timer interval configured. Hello is 10 seconds, dead 40 seconds, wait time 40 seconds, retransmit time 5 seconds, and the next hello should be sent in 5 seconds later. Here we have neighbor count is 1, adjacent neighbor count is 1, adjacent neighbor with quad 2. As you can see, everything can be understood. Okay, this is the information that we have in the show IPv6 OSPF interface. This is so useful for troubleshooting. Then, with the show IPv6 OSPF neighbor, we can find the neighbors of the router 2. Show IPv6 OSPF neighbor. Look at here, we have two neighbors, router 2 and router 3. Both of them has priority of 0 in their interface, because you know that in the serial interface, in the point-to-point network type, we don't have priority. The priority is 0. State is full. We don't have the concept of DR and BDR. This is the dead time, and this is the interface ID of the other side, the interface of router 2 and router 3. And this is the serial 10, the interface of router 1, that we have neighborship on that interface with router 2, and this is serial 11. We have neighborship on the serial 11 with the for example router 3. This is also so useful for troubleshooting. Also, the next command is the show IPv6 OSPF database. About the database we have talked in the previous videos. Show IPv6 OSPF database. This is the database. You know that here we have three link state, three router link state. Also, we have in the router 1, we have 8 link state, and also we have 3, for example, let's say type 9 or prefix or intra area prefix link state. That's it. Also, let me to show you the routing table of the router 1, show IPv6 route OSPF. Here we have this information to the 2001:2/102. The cost is 64, as you can see. You know that the cost of loopback 0 is 1, but when the R2 is sending this cost, it is sending the cost of 0. Because of that, the cost is 64. And here 2001:3/128. Again, we have the cost of 64. The administrative distance is 110, and this is the O route. Actually, for now we can configure the OSPFv3 with classic configuration, and also we know about the different show commands that we have. For example, in the AF or address family configuration, instead of the show IPv6 OSPF interface, we are using show OSPFv3 IPv6 interface. Or a show IPv6 OSPF neighbor can be used with this command, show OSPFv3 IPv6 neighbors. Okay, you have learned about them. Now, after this simple scenario and learning about the configuration of this scenario and also the show command that I have explained, let me to solve two trouble tickets related to the OSPF version 3 classic configuration. This is useful for example, better understanding the configuration and also troubleshooting of the OSPF version 3 with classic configuration. You know that here we cannot use IPv4 because OSPF version 3 with classic configuration doesn't route the IPv4 addressing. This is the OSPF version 3 classic configuration trouble ticket 1. As you can see, we have a simple scenario, include 3 OSPF area 0, area 1, area 2. This is area 2, include R2 and R3. This is area 0, backbone area, include R1 and R2. And also this is area 1, include the R1 and branch. Okay, as you can, branch router is the R4, for example. Here we have only IPv6 addressing, and also we have configured before the, for example, OSPF version 3 with classic configuration. Okay, but here we have one problem. This is the problem. The network was recently updated to reduce the number of LSAs that cross the WAN link from R1 to a branch site. Okay, the only LSA that is supposed to be permitted is a type 3 LSA about the default route. However, reports indicate that more type 3 LSA are being sent from R1 to branch. You know the meaning of the only type 3 LSA, and this means that we expect to working in area 1 as a totally stubby area. Okay, you know that in totally stubby area we don't have any LSA type 5 and also any LSA type 3. Okay, and we have only the LSA of type 1 and also type 2. And also one exception is the default route, that we are receiving the default route from the ABR as a LSA type 3. Because of that, here in the branch router, okay, the problem is that in the branch router we can see the LSA type 3s, okay, but we don't want to receive all of the LSA type 3s, only we want to see only one LSA type 3 include the default route information. Let me to verify the status. For example, in branch router we can verify the show IPv6 route OSPF. This is the for example branch router or router 4. We can check show IPv6 route OSPF. As you can see now, here we have a multiple OI, means inter area LSA type 3 routes, and here we can see also we are receiving the one LSA type 3 include the default route. But as you can see, we have default route, also other LSA type 3s, also other inter area routes, and this is not desired. We expect to see only the OI. I know the reason. The reason is that I think this area is configured as the stub area, not totally a stub area, because this is exactly the behavior of the stub area. In the stub area, we have all of the LSA type 3s include the default route, and also we don't have any LSA type 5. Here we have the similar condition, but we can understand what is the problem. For example, with the show IPv6 OSPF, you can easily find information about the stub area or some other things. Also in the show IPv6 protocol, we have similar information. Look at here, show IPv6 OSPF. Here we can find information about the area 1. Here you can see it is a stub area. It is a stub area means here we are using only the area ID stub. I can show you the command that we have configured before. For example, we can use show running config, okay, section router OSPF or section IPv6 router OSPF. Look at here. As you can see, area 1 stub. This is the command that we have configured. You know that for totally stub area on the internal routers, we are configuring exactly this command, area ID stub. But on the ABR, we expect to see area ID stub no summary. Okay, because of that, about the configuration of the branch router, we don't have any problem. Now let me to show you the information of the show IPv6 OSPF in the router 1. As you can see, in the router 1 for area 1 we have this information. It is a stub area. Here you cannot see any information about the totally stub, but if you want to ensure, you can use show run section router OSPF or section IPv6 router OSPF. Okay, as you can see, again here we have area ID stub, and this is not correct. You know that for a stub, totally stub configuration, we should configure area ID stub no summary. Let me to show you. In the R1, let me to go to the IPv6 router OSPF1, no area 1 stop, but we should configure area 1 stop, no summary. Now this area is the, for example, the totally stubby area. I can show you. Let me to wait some second. You know that in the router 1, now we have this configuration, area ID stop, no summary. In the branch router, we have this configuration, area ID stop without no summary. Okay. Now let me to show you the configuration of R1, show IPv6 OSPF. Look at here. For the area 1, now we have this information. It is a stub area and no summary LSA in this area. This means that I don't advertise the LSA type 3 or summary LSA to this area. This is so obvious. Now, after that, we can verify the branch router, for example, routing table, show IPv6 route, OSPF. Look at here. We are receiving only one LSA type 3, and this is the LSA type 3 of the, for example, default route as we expected before. Also, if you want, you can check show IPv6 OSPF database. You can see we have only one inter area prefix. For example, link asset, this is the LSA type 3 in the OSPF version 3. So easy. This is the first trouble ticket. The first trouble ticket, okay, related to the configuration of the totally stop area. Now let me to talk about the second trouble ticket of the OSPF version 3 classic configuration. Now let me to talk about the OSPF version 3 trouble ticket 2. The scenario or the topology is the same topology, but the problem is another problem. The problem is that branch users means these users are complaining that they are unable to access any resources outside the branch office. This means that from this branch office, we don't have connectivity to the, for example, the LAN of router 1, the LAN of router 3, or some other places in the network. We should find the reason. Let me first try to send traffic from this LAN, okay, to the other network, for example, to the LAN of router 1. It is so easy. Okay, we can use extended ping command on the, for example, branch router. This is the branch router. Conft interface ETH01. Let me to configure the duplex as full, and then interface ETH00 duplex is full. Okay, let me to start with one extended ping command. You can use ping, then enter. The protocol is IPv6. Okay, after that, the target IPv6 address is 2001 db801 double column 1. Okay. After that, repeat count 5 is sufficient. Datagram size 100 byte. It's okay. Timeout in second, 2 seconds. It's okay. Extended command yes. Source address or source interface. Here you can use the IP address of the ETH01, or only you can write here Ethernet 01. Let me to use 2001 db804 double column 4. This is the IP address of the ETH01 interface of the branch router. That's it. And another option should be reside in the default value. As you can see, we don't have connectivity. This means that the problem exists. Why we don't have connectivity from this branch router branch site to the other sites? Okay, we should find the reason. First, let me to show you the routing table. Show IPv6 route. Okay, show IPv6 route is a command that we can use it for verifying the routing table of one router about the IPv6. As you can see, we have only connected networks. For example, the branch router doesn't have any path to the 2001 db801, 2001 db812 double colon slash 64, or 223 double colon slash 64, and finally 2001 db803 double colon slash 64. Okay, here we have a problem. But let me to first verify the OSPF neighborship. You know that we didn't receive any information from the R1. We should find the reason. Show, okay, IPv6 OSPF neighbor. As you can see, we don't have neighborship with the router 1. This means that we have a problem related to the neighborship. Maybe this is related to our OSPF configuration. Let me to use show IPv6 OSPF interface brief, because with this command we can ensure that the OSPF enabled on the ETH00 and also ETH01. Look at here. Yes, we don't have any problem here because we have configured OSPF version 3, okay, in classic configuration over the ETH00 and also ETH01. Process ID is 1, area is 1, it is okay. Interface ID is 3 and 4, it is okay. Cost is 10, and everything is okay. Here we don't have any problem. Let me to show you the status of ETH02 of the R1, maybe the problem related to the R1 interface, conf the interface ETH, for example, 01, duplex is full, and interface ETH02, duplex is full. Okay, let me to verify the status of interface of R1. Show IPv6 OSPF interface brief. As you can see, over the ETH02, we have OSPF process ID 1 and area 1. It is okay. We don't have any problem about the OSPF configuration. Also, show IPv6 OSPF neighbor. It can show us we don't have neighborship with the router branch, means with the router 4. We have neighborship only with the router 2. Actually, here we have a problem. As you can see, about the OSPFv3 configuration on the interfaces, we don't have any problem. This is the one of the features that we should verify. Also, after that, let me to check the other features. For example, we can use show IP OSPF interface name. Look at here in the R1, show IPv6 OSPF interface, then ETH02. It can show us that hello time is 10 seconds and dead time is 40 seconds. It is okay. Also, the network type is broadcast. Okay, we should check them. Network type should be same between two sides. The hello and dead time should be same between the two sides. And here, as you can see, we don't have, for example, authentication. Very good. Let me check the branch router. Show IPv6 OSPF, for example, interface ETH00. Here, as you can see, we have different hello time. Hello time is 30 seconds and dead time is 120 seconds. And the network type is non-broadcast. You know that in network type of non-broadcast, the default hello time is 30 seconds and default hold time is 120 seconds. Actually, here, the administrator doesn't configure for example, different dead time and different hello time. This is because of the different network type, okay? We can check it. If you want, you can use also, for example, show run, then section IPv6 router, or if because the network type should be configured on the interface, we can use show run interface ETH00. Look at here. On the ETH00, we have this command IPv6 OSPF network non-broadcast. Okay, this is the network type of this interface, but on the R1, show run interface ETH02, we don't have this command, and because the default interface type on the Ethernet interface is broadcast, now we have this mismatch. We have mismatch in the network type, and the result of this mismatch is the mismatch in the hello time and dead time. Also, with debug IP OSPF hello, if you want, you can verify the problem. Debug in the router 4, for example, in the branch router, debug IPv6 OSPF, for example, hello. Look at here, events is good, but hello is better. Look at here, OSPF version 3 hello debugging is on for process 1 IPv6, and we should wait some second. Yes, we are receiving hello from router 1. Okay, mismatch hello parameter. Okay, we are receiving the hello as the 40 second. Okay, and also we are receiving dead time as the 40 second, and we have configured 120 second. Actually, we didn't configure the dead time. We configured the network type, and because of the network type, the dead time, okay, configured to the default value of 120 seconds. We should remove this command over the branch router. Let me to undebug all. Then over the ETH00, conf the interface ETH00, let me to use no IP OSPF network or no IPv6 OSPF, okay, network. And after that, for example, that's it. Okay, now the ETH00 is using its default network type. Do show IPv6 OSPF interface ETH00. It can show us now on this interface. We are waiting for DR and BDR election, and as you can see, the network type of this interface is broadcast, and because of that, the hello time is 10 seconds and dead time is 40 seconds. We should wait for selecting the DR and BDR. After that, we will not have any problem. Look at here, show IPv6 OSPF neighbor can show us that now we are residing on the two-way state, and show IPv6 root OSPF show us we didn't receive any root from the OSPF because we don't have neighborship between the branch router and R1 until the neighborship between them is establishing. We should wait again, show IPv6 OSPF neighbor. Okay, the state is two-way. Okay, and both of them now are DR other. After 40 seconds, one of them is DR, another is the BDR, and after that they are exchanging the link state with the for example each other. Show IPv6 OSPF interface ETH00 can show us the remaining time. Okay, as you can see, wait time before designated router election is for example 44 seconds. You know that the default value is 40 seconds. Okay, now we should wait more 31 seconds or 30 seconds. After that we will receive the information. You know that about the OSPFv3 and classic configuration, we have many similarities with the OSPF version 2. Actually, everything is same. Only about the LSA types, we have some change. You have learned about them. Also, we have some new options such as the different authentication type, and also about the instance ID and some other things. We have some differences, but the main function, the basic function of both of them are same. Now we have neighborship. Show IPv6 OSPF neighbor can show us we have neighborship, and show IPv6 root OSPF can show us we have one for example a default, because this is a totally stop area. If you want, you can if you want to check the connectivity, you can use this command, because this is a totally stop area. Here in the branch router, now we have neighborship. We can use ping command again, then IP protocol is the IPv6, and then destination 2001 db801 double colon 1, repeat count 5, datagram size 100 byte, timeout into second 2, extended command yes, and source inter IP 2001 db804 double colon 4. After that we can see that we have connectivity. Also, if you want, you can remove the stop configuration or totally stop configuration on the router 1, IPv6 router OSPF1. Okay, for example, we can use no area stop or area 1 stop, no summary, and also in the branch router conft IPv6 router. Okay, OSPF1 no IP no area 1 stop. That's it. Because of that, after this command, you will see that we have the addresses of the other areas in this router. Show IPv6 root, for example OSPF. Look at here, we have all of the LSA type trees, and because of that, now we know that the reason of this problem related to the different network type, and as a result different hello interval, and also dead time of for example between the router 1 and branch router. You know that one of the neighborship conditions in both OSPF version 2 and OSPF version 3 is that the network type should be same, and also the hello interval and dead time should be same between two routers. Until now we have learned about the OSPF version 3 classic configuration, troubleshooting, and also configuration. Okay, I'm going to talk about in the next video about the OSPF version 3 with the AF address family configuration, and also some trouble tickets related to the OSPF version 3 address family configuration. You should review this video. You should complete the configuration and also troubleshooting scenarios. After that, please come with me to the next video. We will learn about the OSPF version 3 address family configuration and troubleshooting commands, and also the trouble tickets related to this implementation of OSPF version 3.